I'm using this modified Softrock ensemble to test reciprocal mixing in sound cards. The signal sent into the Softrock comes from here, a low noise crystal oscillator with an attenuator, and a second attenuator here, which is set to 0 attenuation, and in this position it gives -8 dBm to the Softrock. Right now I'm running with the DMX 6 Fire PCI card, and I have clicked on the signal and adjusted the S meter to show -8 dBm. And then I changed the frequency in steps of, I think it was 5 kilohertz, yes. So now 10 kilohertz away, the noise floor is at -117 or something like that. 20 kilohertz away, that's the normal standard frequency where mostly phase noise of radio receivers are reported. So I read this value out. And I find -119.5. And then I step further upwards in frequency, looking for artifacts and problems that might show up. Looking at the S meter here, and you see it goes down pretty quickly. And looking here, you can see a nice flat spectrum. I'm now 100 kilohertz away. Occasional spurs, but not very strong ones. So I go back 14.16. Well, 17, that's the signal. 5, 10, 15, 20. And I go back to where the reference noise floor is. -119.5. The next sound card is the ESI Maya 44. And I have set it up. Main spectrum looks like this. And the S meter is calibrated to show -8 dBm, which is still the signal level. And I step the frequency 5 kilohertz, 10, 15, 20, and read out what is this noise floor from here to here, -112.8. And I switch off the strong signal, and you can see not much of this floor is reciprocal mixing. I have restored the full signal and go upwards in frequency, looking for possible unpleasant things on the S meter. And I'm also looking at the main spectrum to see if something comes up. There are some spurs that accidentally might come into the 1 kilohertz bandwidth I'm using, but I disregard those. They are very far below the main signal and not so dangerous as noise humps or white noise would be in an SDR context. The next card to test is the Steinberg UR12 USB box with this control window where I told it to use 96 kilohertz. At minus 8 dBm, this unit is saturated. I have to use this attenuator and reduce the signal. 1 dB, 2 dB is fine. So I have now minus 10 dBm as the input level. The signal has noise humps on both sides. And if I move the frequency for the signal to come closer to the center, they become weaker, as you can see. And if I go in the other direction, moving near the edges, they become stronger. So I measure the reciprocal mixing noise by putting the signal here first, and here I calibrate it to show minus 10 dBm, because that's the level we have. Oops, so minus 10. And then I move 20 kilohertz upwards, or to the worst position. 15 kilohertz up is the peak of this noise. And what we see, the level of it, is minus 114 dBm. It looks like the phase noise of a poorly designed PLL. I continue upwards to see if there are any oddities to find. And it looks flat here, and I don't see anything here. And I continue a bit further. And this is a spur. As large separations, this is quite good, but this unit suffers from close range phase noise on the sampling clock. The AKAI EIE Pro, it needs 1 dB of attenuation here to not saturate, means minus 9 dBm, and that's how the S-meter is calibrated. And I now step the frequency, 5, 10 kilohertz, and the noise floor is minus 117 or something, 15, 20, and this is where I read out the noise floor if there is no reason to look at some other frequency where things are interesting. Means not so good. And this readout stuff doesn't always work, but often it's something with the left and right mouse buttons that I have not programmed properly. Anyway, 118, minus 118 dBm. And I continue upwards, looking for possible artifacts or problems with this sound card. Looking here, and also at a wide spectrum. But holding the camera too far away will show nothing, so I just look here. And it's obvious the noise floor stays at a nice and low level. Means we don't have problems with phase noise. Not much, at least. I'm now pretty high above the signal frequency. This is the StarTech Virtual 7.1 sound. It looks like this on the Linrod screen, and the volume has to be set to 0, and it saturates at minus 10 dBm. I have to set the attenuator to 2 here, and I step the frequency upwards, calibrate it to 10. I think I don't know if I said it before. 1, 2, that's 10 kilohertz away, minus 112 or so, 20 kilohertz away, similar. And I continue upwards. The noise increases. So this is phase noise. And as I go up in frequency, the noise floor goes up. And it seems to flatten out here, 200 kilohertz from the signal. Then it goes down again. It's a pity, otherwise this would be the most cost-effective sound card. Well, it isn't so bad really, but what I do recording the noise floor is I go for the more or less worst we have. I'm not measuring at 20 kilohertz. I measure, let's say, 150 kilohertz from the signal. There the noise floor is at minus 106 dBm. Now I'm running the M-Audio Delta 44. This card is completely without any modification, and I'm running it in consumer gain position, because that gives the best dynamic range for this card. The screen looks like this, the wideband thing, and the S meter, it's calibrated to show minus 8 dBm because I have no extra attenuation. And I step up 5, 10, 15, 20 kilohertz and see no particularities. So I read out the noise floor here. Well, once more. Minus 114.1. And then I go upwards in frequency, looking for possible increases of the noise floor. And I don't see any problems with this card. And the performance I could see was 114.1. The M Audio Revolution 5.1 has different sensitivity on the different inputs. I think the line input is the best one. It comes 5.5 dB below saturating the sound card when I run -8 dBm into the Softrock. And I have calibrated, of course, the S-meter to show -8 dBm. And I step the frequency 5, 10, 15, 20 kilohertz and look at the noise floor, and it looks good. So I take a reading here. -118.3. And then step further upwards to see if there is some peculiarities. And look at the noise here. And on the S-meter. It goes down towards -120 at 100 kilohertz separation. That's fine. And I switch off the strong signal, and you can see there is very little reciprocal mixing. Probably from the SI 570, but it could be the sound card also, I don't know this.